Friends, welcome to this channel Dr.ARM's Chemistry. We were discussing metal carbonyls and up till now we have seen the introductory part of this topic. Then we have seen the characteristic properties also or features. And we have also seen the 18 electron rules for these metal carbonyls. And now we will see the next point in this topic, that is preparation of these metal carbonyls. So there are several methods by which we can prepare the metal carbonyls. We will see these methods one by one. First of all, the metal carbonyls can be synthesized directly from their metals in pure state and the carbon monoxide. So in this case, we can prepare the metal carbonyls of nickel and iron, and these metal carbonyls are used to obtain pure nickel and iron. So nickel carbonyls and iron carbonyls are used in the industrial purification of these metals. So directly the reaction takes place between the metal and the carbon monoxide. Additionally, sometimes the temperature required is relatively higher, that is elevated temperature, and pressure is also required in some cases. In this case, finely divided iron is used at room temperature. All other metal carbonyls are prepared by using variety of forms of metals. Sometimes the pure metal, as we have seen here, the metal can be used in the form of their halides, acetates and any suitable form, so that we can prepare the metal carbonyls. The conditions provided for the preparation are reductive. So we are using here reducing agents. That is, the metal carbonyls are prepared by using the reducing agents such as sodium, aluminium, alkyls, zinc and carbon monoxide, etc. So carbon monoxide may be sometimes mixed with hydrogen. And now we will see the preparation of dicobalt. Preparation of dicobalt. Dicobalt carbonyl. So this is prepared at the specific temperature and pressure conditions. So here twice CO3 plus twice H2 plus 8 CO. So here the pressure conditions are like this: 250 to 300 atmosphere pressure, and temperature is 120 to 200 degrees centigrade. So this gives us CO8 plus twice CO2 plus twice H2O. So in this way we can prepare the binary metal carbonyls or binuclear metal carbonyls. Then other binary carbonyls are prepared from using metal halides. So using metal halides. The first method shows that in 1868, the scientist Suzenberger prepared this metal carbonyl prepare this metal carbonyl twice. For the first time, using the reaction PtCl2 plus CO gives here PtCl2 CO twice plus cis PtCl2 CO2. So here we can see the formation of a metal carbonyl in different way, in which there two coordination points are used by Cl, that is halides and carbon monoxide. So it is giving also very important complex cis platinum Cl2 PtCl2 CO2. Then it will include variety of reactions such as so the examples of this method are formation of the metal carbonyls of nickel and iron, that is NiCO4 and FeCO5. So this is used for refining of metals, that is nickel and iron in industries. So nickel is directly reacting with carbon monoxide in presence of pressure, that is 1 bar and 25 degrees centigrade. So we get NiCO4. So this is colorless and it has melting point minus 17 degrees centigrade, and this is melting point and boiling point is 42 degrees centigrade. Another reaction is say Fe plus 5 carbon monoxide under the conditions of 100 bar, that is pressure, and 150 degrees centigrade, that is temperature, and it gives a FeCO5. So this is pale yellow product and it has temperature minus 20 degrees boiling point. Melting point is minus 20 degrees centigrade and boiling point is 103 degrees centigrade. So this method is easy to operate. Second method is reductive carbonylation, that is we can say B, reductive carbonylation. Here this is very commonly used method and it makes use of the variety of reducing agents such as aluminium, sodium. The reducing agents are aluminium, sodium, zinc. Then AlR3, that is trialkyl aluminium, and Grignard reagent or MgX cancer. So metal is used here as halide. Metal is used here in the form of halide. The conditions required are high temperature and high pressure conditions. So we will see some examples of this. So first of all, we will see the CrCl3 plus Al plus 6CO. It requires the C6H6, the solvent AlCl3, catalyst, and the conditions 300 bar pressure and 140 degrees centigrade temperature. So it gives the CO6, that is our metal carbonyl, and the product is AlCl3. Then another example is molybdenum MoCl5 plus sodium plus carbon monoxide 6 under the conditions, that is diglan as a solvent, 62 bar pressure, and the range is temperature minus 10 to minus 25 degrees centigrade. So it gives the product MoCO6 plus 5 NaCl. So here this diglan is the methoxy ethyl ether. Diglan is this methoxy ethyl ether. Methoxy ethyl ether. That is we can show this as CH3 CH2 CH2 twice O. That is methoxy ethyl ether. It is also called bis 2-methoxy ethyl ether. Now the reaction vanadium trichloride plus 4 Na plus 6 CO under, that is solvent diglan, and 300 bar pressure. 300 bar pressure. So it gives diglan 2 and VCO6. So this on treatment with H3PO4 followed by sublimation at 50 degrees centigrade gives the VCO6 product. Then next reaction we will take VCl6, this is custom carbonate plus thrice Zn plus 6CO. Under the solvent is ETO. Ethyl ether at 67 degrees centigrade and 50 atmos pressure. So it gives tungsten, that is CaWCO6 plus thrice Zn Ca2. Then another reaction is of ruthenium RuCl3, then thrice H2O plus carbon monoxide plus H2. So this under the condition of 2-ethoxyethanol, at 80 to 135 degrees centigrade and 1 atmos pressure, or the another condition can be considered here is KOH and 75 degrees centigrade of temperature and zinc. So it gives ruthenium Ru3CO12. So these are treatment with carbon monoxide at 160 degrees centigrade and 200 atmos pressure gives RuCO5. RuCO5. So in this way you can get this carbon monoxide. Now we can also see the reactions in which the acetates are used of these metals for the preparation of their carbonyls. So we can see the example of preparation of metal carbonyls of Mn using their acetate. That is twice MnO OEC2 plus 10CO plus Al-ET3 triethyl-aluminium. So here isopropyl ether is used as a solvent and pressure is 207 bar. Temperature is 80, 200 degrees centigrade, and the product is Mn2 CO10 plus AlOAC3 plus C4H10. So in this way we get these dinuclear metal carbonyl of these Mn. Now we will see another example. Twice MnOEC2 plus 4Na plus 10CO under the conditions of solvent DME and 165 degrees centigrade temperature, 240 bar pressure. So it gives Mn2 CO 10 plus this 4 NaOEC, sodium acetate. Similarly, we can prepare the ruthenium polynuclear carbonyl using the acetate of ruthenium Ru, CO, Ru, ACAC, acetoacetate thrice plus 12 CO plus 4.5 H2 means 9 hydrogens are required. Solvent is NaOH, 150 degrees centigrade temperature, 155 bar pressure, atmosphere pressure. Atmosphere pressure. It will give the trinuclear product, that is Ru3 CO12 plus 9 MeCO CH2 CO Me. Another example for the preparation of tungsten using its halide WCl6 thrice FeCl thrice FeCO at 100 degrees centigrade. It gives WCO6 plus thrice FeCl2 plus 9CO. So in this way we can make use of the metal halides. And the third method is use of metal as metal oxides. Third method, using metal oxides. So here, reducing agent is carbon monoxide itself, and the reaction conditions are more drastic. That is, very high temperature and high pressure is required here. So we see some examples. That is thrice osmium tetroxide plus 16 carbon monoxide using the solvent NaOH at 125 degrees centigrade and 75 atmosphere pressure. So it gives trinuclear, that is OH3CO12 product plus 4CO2. Similarly, another reaction is using rhenium Re2O7 plus 17 carbon monoxide under the conditions of 215 atmosphere pressure and 290 degrees centigrade of temperature. It gives dinuclear, that is Re2CO12 and 7 CO2. So here some of the carbon monoxides are oxidized and thereby it reduces these alkyls. We will see say another thrice RuO2 X H2O plus 18 carbon monoxide toluene 20 atmosphere pressure and 160 degrees centigrade temperature gives Ru3 CO12 plus CO2 6 CO2. Then we are also showing the example of cobalt oxide, that is COO plus 10 carbon monoxide under the conditions of 1900 atmosphere pressure, 80 degrees centigrade of temperature, giving CO2 CO8 plus twice CO2. Then another reaction is Fe2O3 plus 30 carbon monoxide under the conditions of 200,000 atmosphere pressure and 225 degrees centigrade of temperature gives twice FeCO5 plus thrice CO2. Then another reaction is molybdenum MoO3 plus 9 carbon monoxide at 2000 atmosphere pressure and 380 degrees centigrade of temperature gives MoCO6 plus thrice CO2. Then another reaction is twice CO3 plus twice H2 plus 8CO at 100 to 150 degrees centigrade temperature and 240 per bar pressure gives CO2 CO8 plus twice CO2 plus twice H2O. So in this way, so these are two reactions we have seen. Here the metal is used in the form of oxides and here we have taken this metal in case of in the form of carbonate. So what is other methods? So these methods are specially used for metal carbonyl clusters. So here these metal clusters are industrially important and useful for various applications. So we will see some of these examples. For Na3 IR Cl6 plus 12CO using solvent NaOH reflux at 1 atmosphere pressure, it gives tetra IR4 CO12 plus NaCl. Then another reaction in this case is twice RH sodium trichloride thrice H2O plus 4 carbon monoxide There we are using the same solvent in the weight at 100 atmosphere of pressure, 100 degrees centigrade, 100 degrees centigrade, and 1 atmosphere of pressure. Then it gives RH CO2 Cl2 twice. So this represents in heptane this one using carbon monoxide and water and NaHCO3. It gives the cluster RH4CO12 cluster carbonyl, that is RH4CO12. This next reaction 6 RHCl3 thrice H2O plus 16 CO under the conditions of MOH 60 degrees centigrade, 40 to 50 atmosphere pressure. It gives RH6 CO16 cluster of carbonyl compound. Then next reaction is tungsten WMe6, that is alkyl of this tungsten, and excess of carbon monoxide. So this gives WCO6 plus thrice 3-methoxy, that is 3NH2CO. Then another reaction is RHCl triphenylphosphine PPH3 thrice plus RCHO gives RHCl CO PPH3 twice plus RH. So in this way, you can have these reactions: Ru, NH3 5, H2O 2 plus. So after the reaction with carbon monoxide, it gives Ru, NH3 5, CO 2 plus. Then next reaction is twice Fe CO5 using sunlight. That is for the photolysis, gives Fe2 CO9 plus carbon monoxide. This is photolysis. Then another reaction is thrice Fe CO5 plus 6OH minus thrice HCO3 minus gives thrice HFE CO4 minus. So this are treatment with MnO2 gives 83 CO12 plus thrice OH minus plus thrice MnO. Then another reaction is twice CO2 CO12 CO2 CO8. So this on reacting at 70 degrees centigrade, that is thermolysis gives CO4 CO12 plus 4 carbon monoxide. Then another type is disproportionation reactions. This other method, disproportionation reactions. Means self oxidation reduction in the same molecule. Means one molecule undergoes reduction, another molecule undergoes oxidation. So that is called disproportionation reactions. That is self-oxidation reduction. So here we will see some examples. For example, twice NiCN plus 4 carbon monoxide gives NiCO4 plus NiCN2 NiCN. Here you will see this NiCN is a +1 oxidation state. This Ni means out of say 2 molecules, one is undergoing reduction, so it is converted into 0 oxidation state. So Ni plus 1 is reduced to Ni0, and this Ni, another molecule, is oxidized to Ni2. So that is called self-oxidation reduction. Another example is K2 NiCN3 plus CO, that is gives K2 NiCN3 CO. So here this Ni is in the +1 state. This is also in the +1 state. Now if we take this twice, that is K2 NiCN3 CO plus twice CO gives NiCO4 plus K2 NiCN4 plus twice KCl. Twice KCl. Here this Ni is in +1 state. So after undergoing self reduction, some Ni is half of the Ni is reduced to Ni0, and another Ni is reduced or oxidized to Ni2, that is 2 plus state. Then we will see third reaction, that is thrice Mn2 CO10 plus 12 pyridine at 120 degrees centigrade and minus 10, that is loss of carbon monoxide, minus 10 CO. So this gives twice Mn Py6 2 plus 4 Mn CO5 minus. So this is also the example of self-oxidation reduction. Now, oxidation of metal carbonyl hydrides. By oxidation of metal carbonyl hydrides by MnO2 or H2O2. So here we get thrice H2 FeCO4 by the action of H2O2, that is using thrice oxygen, it gives FeCO4 thrice plus thrice H2O. Then this last method, that is other methods using mixture, that is formation of mixed metal carbonyls. So in this method we will see how the mixed metal carbonyls are prepared. So first example is this MnCO5 minus plus this BrReCO5. So it gives CO5 MnReCO5. Plus Br minus. Another example is twice CO4 minus plus trans PTCl2 Py2. So it gives CO4 CO PTPY PY CO CO4 plus twice Cl minus. Then third reaction is OH3 CO12 plus Re CO5 minus. Then H plus gives H3 Re OS3 CO12. Then Re3 CO12 plus CO4 minus. The same way, then H plus gives HCO Re3 CO13. So these are metal carbonyl hydrides. So these two are carbonyl hydrides. So this is about the preparation of metal carbonyls. So we will stop our discussion here, and next lecture we will see the structure of metal carbonyls. So till then, see you. Goodbye. Please, if not, please subscribe to this channel and press like button also. Thank you very much for watching this lecture.